Hello everyone, welcome back to Math 245. This week we've been talking about binomial distributions and binomial probability. Today we are going to do something called conditional probability. So if you remember a few lessons back, we talked about what it means when two events are independent of each other, and we said that the probability of A and B happening was the probability of A happening times the probability of B happening. But this is true only if A and B are independent, which means that A happening does not affect whether or not B happens. So today we're going to talk about when that's not true, so when picking A does affect B and how we do that probability. So here's our definition for the day. The probability that the event B occurs, given that the event A has already occurred, is represented as this right here, which is read as the probability of B given A. So that bar is like given. So if events A and B are not independent, then the probability of A and B happening is the probability of A happening times the probability of B given A. So this is what we're going to work with today. Let's look at the first example. What is the probability that two cards drawn at random from a deck of playing cards will both be aces? So we are dealing with the probability that the first card is an ace, and we also want that the second card is an ace. So if I look at this equation right here, I can write this as the probability event A is the first card is an ace, multiplied by the probability of B given A. In this case, B is the second is an ace, given that the first is an ace. So this will be the probability that the second card is an ace, given that the first is an ace. So what is the probability that the first card that you draw is an ace? Well, there are 4 aces in a deck and there are 52 cards. What about the probability that the second card is an ace given that the first one is an ace? So you've already drawn one card. So there are only 51 cards left, and there are only 3 aces left. So we have 3 possibilities, 3 aces out of 51 cards. So this 3 over 51 is the probability that the second card is an ace, given that the first card is an ace. So if I multiply these two together, I get 0.00452, which is 0.452%. So pretty unlikely that you will draw 2 aces, but it is possible. Okay, let's do another example. The table below shows the number of survey subjects who have received and have not received a speeding ticket in the last year. It also shows the color of each subject's car. So we have, this is a special kind of table that we will deal with in the next example as well. So here we have speeding tickets for if you are driving a red car and if you are not driving a red car. And then we have no speeding tickets, again, for not driving a red car and for driving a red car. So this is the total number of speeding tickets. This is the total number of not speeding tickets. This is the total number of red cars, and this is the total number of not red cars. So let's do some probabilities here. Calculate the probability that someone got a speeding ticket given that they were driving a red car. So we want to calculate the probability, well, yeah, I'm not going to write it down, given that they were driving a red car. So how many people are driving a red car? 150 people total drove a red car. So we have 150 possibilities for driving a red car. What about how many possibilities are there that they got a speeding ticket? Well, that is 15. So there are 15 people who got a speeding ticket and are driving a red car. So this is 10%. So again, this 150 is the total number of red cars. This 15 is the number of speeding tickets given that they were driving a red car. Okay, calculate the probability, 150. Calculate the probability that someone drove a red car given that they got a speeding ticket. So we have a speeding ticket. How many do we have total? We have 60 speeding tickets. So that is the total number of possibilities. And of those 60, how many of them were driving a red car? 15 of them. So this means that if you got a speeding ticket, the chances that you are also driving a red car is 1/4 or 25%. So this table comes in very handy, but we need to be careful when we are reading these kinds of tables, as it has a lot of information in it. So we just have to be careful that we are gleaning the right information from the table. Okay, in the next example, the last one, we are actually going to construct this table on our own. So we have a school of 1,000 students, and 600 of them study physics, 300 study calculus, and 100 study both. What is the probability that someone who does not study calculus studies physics? Give your answer as a decimal to one decimal place. Okay, so we want the probability that a student studies physics given they do not study calculus. Okay, so this is what we want. And if we go up to this equation up here, let me rewrite this down here. So in this case, I'm going to call event A not calculus. And I'm going to call event B physics. So if I look at this equation up here, I get that the probability of A and B is equal to the probability of A times the probability of B given A. So I have P of A and B is the probability of A times the probability of B given A. So if I want to solve for the probability of B given A, then I need to divide both sides of this equation by P of A, P, the probability of A. So if I divide both sides by P of A, I get that the probability of B given A is equal to the probability of A given B divided by the probability of A. We just use some algebra to rearrange this equation since I'm trying to solve for P of B given A. So I just moved some things around in our equation to isolate that. So in this context, this is the probability of A intersect B is not calculus and studying physics, and probability of A is just probability of not calculus. So we know some things here. First of all, I have 1,000 students, and how many of them are studying physics? Well, that is 600 students out of 1,000. So the probability that somebody is studying physics is 0.6. How many students are taking calculus? Well, 300 out of the 1,000. So this is 0.3. And what about calculus and physics? So that's 100 out of 1,000. Whoops, I dropped a 0 there. Or 0.1. So this is what we know. But I don't know calculus and not physics, and I also don't know not calculus. But we will get there. So I'm going to draw a table similar to the previous example. So let's draw this. We will have calculus. How many students are taking calculus? How many students are not taking calculus? And the total here. So that is going down. And then on this other side, we'll have physics, not physics, and total. So we know that the total number of people who are taking calculus is 0.3 from up here. We already know that the total number of people who are taking calculus is 0.3. We also know that the total number of people who are taking physics is 0.6. So that should be 0.6. Okay, what about calculus and physics? Well, calculus intersecting with physics is right in this spot right here, so this is 0.1. Now I can fill in this table a little bit. So in this spot right here, we are asking how many students are taking calculus but not physics. Well, in this column adds to 0.3. Oh, excuse me, this row adds to 0.3. So in this one right here, I'm going to have 0.3 minus 0.1, this guy. So that will be 0.2. All right, and this right here, I'm trying to figure out how many students are taking physics but not calculus. Well, I have that the total in this column should be 0.6. So here I will have 0.6 minus 0.1, which is 0.5. All right, I still have some other stuff to fill out, but I have to use a trick here. How many students combined have to take calculus and not calculus? Well, if you're not taking calculus, if you're taking, so the total here has to be 1, right? You're either taking calculus or you're not taking calculus. So I want this to add to 1. So I need whatever goes in this slot right here to add to 1, because that is the total of people who are taking calculus and people who aren't taking calculus, and that's everybody. So this has to be 0.7, which is 1 minus this 0.3. I also know that I need this. This represents people who are taking physics and people who are not taking physics. Again, that's everybody. You're either taking physics or you're not. So that number has to add to 1 as well. So this has to be a 0.4. That's 1 minus 0.6. So we only have one slot left, and we can do this a couple of different ways. I know that in here, my total has to add to 0.4, and here I have 0.2. So this could be thought of as 0.4 minus 0.2, which is equal to 0.2. We could have also done this as 0.7 minus 0.5. It would have given us the same thing. All right, now we are ready to fill in our equation. Remember, we want the probability of physics given not calculus. And we said that our formula for this was the probability of not calculus and physics divided by the probability of not calculus. So what is the probability of a student taking not calculus and physics? So not calculus is here, and I see that this right here represents not calculus and physics, 0.5. And what about not calculus? Well, that is this right here, so that will be 0.7. And if I were to calculate this, this would be 0.71 or 71%. So the probability that someone who does not study calculus studies physics is 71%.